In this video, we are going to learn how to implement a hash map in JavaScript. The purpose of this exercise is to learn the algorithm for hash map. It is not meant for production use. First, let us understand what is hash map. Hash map in Java. Okay, here you can see in HashMap actually we will have an array, and the elements of that array is a linked list. This is what we need to design, a main array which is an array of linked list. That's what we want to design. So yeah, the items in the hash map is a key value pair. You can see here this is a Java hash map. Here you can see the put, so you can save data as a key value pair, key value. So basically what we need to do is that one, using that key we need to find a number associated with that key. We will learn how to find that number. Assume that when you will get a number based on that key. For example, you have a key 1 and you get an associated number is 0, then you will store in this linked list. If another key its associated number is 3, then it will store here. So that's what we are going to do. We will have one array and a linked list. We'll design that one. Okay, let me start with first we need element. We need a class for we need a element. I will call this entry, which will contain a key value pair. Class entry. I will define a constructor which will contain key value, and this element is you can see that one, it is in the linked list. Obviously a linked list should contain a pointer to the next element, so we need to define one more item here. That's the next, it's the next pointer to the entry. Next entry, I will give next entry that one. Okay, now here we will save that one. This key equal to this value, this next entry, we store that one. We got the element in the linked list, item in the linked list. Now we need to define hash map. I will call this my hash map. My hash map .js. This is also a class, my hash map. What is the constructor should be in the my hash map? So you can go here, you can look at here. There are in Java there are 4 constructor. one is the empty construct an empty hash map with the default initial capacity. Okay, initial capacity 16 and the default load factor is 0.7. The capacity says that the size of the array. So here you can see 16 sizes. So that's a default one. And the second constructor receives the initial capacity. So I will do one thing in in JavaScript you can define only one constructor, I think. So here I will write capacity and this dot capacity, this dot capacity. So you need to pass the capacity here. You can define a default capacity, capacity. In Java it's a 16. Here I will give initial capacity is 1. I will give as a default value. Okay, so we created a hash map and entry. Now we need this array. We need to create this array associated with the hash map. So I will call that array buckets. I will define this buckets here. This dot buckets. This is an array. New array. I will define the size also. This dot capacity. Now we need to define two main functions. One is the get and another one is put. See, get accepts the key and put accepts key and value. Put accepts key and value. Okay, so get it accepts key, I will define that one. Put accept key the value. Now what you need to do is that one you need to find basically you get key, you need to store in the bucket. So key here, it should be assume that it's a string. From that string you need to find a number. How to find a number in the string, so that you will you basically you want to store this value in the bucket. A bucket is indexed. It's an array which contains index 0, 1, 2, 3, but the key we got is string, so we need to convert that string into a number. Okay, so let's do one thing. I will define one more main function, main file, main.js. Okay, actually this is a Node.js. I am going to run with the Node.js, so you can export this one. Module dot exports. You can export this entry here. The same way my hash also you can export here. Module dot exports my hash map. Now you can go here in main and constant my hash map require my hash map constant my hash map new my hash map. Yeah, now what I will do is that one I will define a loop adding values to hash map. So I will define a for loop I is equal to 0, I less than 10, I plus plus. So here what I will do is that my hash dot put key plus I, basically key 1, key 2, key 3, key 4 up to key 9. I will give value as v I. This is how I will add that one. Now what I will do, okay, adding this one. Now basically what we want to do is that we want to store this key in the buckets. So what I will do is that on here we need find out a number for that key. So let me call this hash code. We'll get key here. Basically we won't code key here. Actually it's called name and value. Name and value. How to find a number associated with that string? Here we sending actually k1, k2, k3, k4 and all up to k10. How to find that one? I will do one thing. For the time being, I will add a name dot length. Length of the string is you will get a each string length you will get that is a number, right? Associated number for that string. Here we are running 1, 2, 3. I will add one thing. I will add here 16 up to 15. So first 10 items size is 1 and the rest of the strings size are 2. We will change that one, but let us start like that now. So here you can see I return a name.length. Now that's a hash code. Now what we want is that one get bucket index using that name. How to that bucket index you will get? You need to do the first get the associated number from that you will get the associated number for that name, then use the modulo operator and use the capacity, so that we will basically we have a bucket, its capacity is this dot capacity. So we want to make sure that one the bucket index we are making is under that capacity. For that purpose we are using modulo. So if it is going beyond the capacity, we will discard the that part and the rest of the body will get. For example, capacity is 10 and the hash code is return is 12, then modulo will return 2, so that it will come under the valid boundary, get bucket index. Okay, now what I will do is that first we need to bucket index constant bucket index equal to this dot get bucket index name. We got a bucket index. Next what we want to do is that constant next this dot bucket. First bucket index. First take that value in the bucket index Then create the new entry to add entry. This code I will change later, but first I will come up with some simple code. Key value, then next. Okay, basically what I have done is that I want to add one value in the 3. Then what I will take is that I will take the head of the linked list, and that first we will create here. Basically what I am doing is that I am taking this head. This is a this dot bucket index. That means this 3 is pointing to starting of the linked list. We can call that head of the linked list. I'm taking that one, I'm storing as a next. It's a head of the linked list. Then I'm creating new entry, and that entry contains that head. Now this entry became the head. Now then we need to add that entry into the bucket. Okay, and basically I took this value and I created a new entry, and the head is attached to the new entry. Then new entry went into the bucket. That's what I have done here. Now let us do this getting here. The same way getting in, first we need to get a bucket index for that particular name. Using the get bucket index, we will get basically a number. We will get. We will take the key. Name is here basically a key. I think name is bit confusing. Let us change to key everywhere. Refactor is everything. I'm not sure how that's work. Key. I think I have written key here. Here also I will give key. Okay, yeah, we got the bucket index. Then take the entry in the bucket. Basically it's the head of the linked list. This one, we took that head. Then we will check the head should not be null. Then check if head dot key is equal to key, which means the entry is matching with that key. Then return head dot value. It will return the value. Otherwise head should be pointing to the next element in the linked list. If didn't match anything, we should return null. I will explain this once again. We want to find out the value of the key, particular key. First we need to find out the index associated with that bucket, associated with that key, index for that key. So we will use this function. This function will return a number for this key. Key is usually a string. It will come up with some number. Currently we wrote length of the key. We will change that one, but let us assume we are getting some number. That's a bucket index. Then we are talking about the get. Yeah, then we will get we are taking that value in the bucket index. So in this case, it contains head of the linked list. So we store as a head. It is a entry to that linked list, and we are checking whether it's null or not. There are here 1 and 2 are null actually. So we are checking if it is not null. We are checking whether that head key is the same as the key we want to search. If it is true, then we will return head dot value. Otherwise, we will go to next value. First, we will check this entry, then we will check this entry. If nothing matched, we will return null. So put also we return like that only. We want to store a key with the value this one. First, we will find the what is the corresponding bucket index for that key. Once we got that one, we will take that bucket and store in the next. Basically, it's a head of the linked list. That one, we took that head one and created a new entry, and that entry went to that bucket. Okay, we got a entry class, and we got a HashMap class, and here we are storing almost 15 values. I will do one thing. I will run and check it. Yeah, we got a entry, main, and main HashMap. I will use a node to run that JavaScript file. We got some error. Default capacity is not defined. Basically, static default capacity. Okay, you need to use this class name here. Use this class name here. Entry is not defined. Okay, we didn't import the entry. So in the my HashMap, you are using entry, but we didn't import that one. In Node.js, it's require. We need to use require entry. That's it. Yeah, everything successful. Added everything. So basically, what we have done is that we inserted almost 16 values into my HashMap. Now we want to make sure that whether it's successfully inserted or not. We need to verify that one. So for that one, what I will do is then verify put. Okay, so for that, what I will do is that one, I will use another loop, and I will check if my HashMap get this is the key where I am getting that key, then is it equal to b plus I1? Checking whether it's equal or not. If it is not equal, print that one. Console.log I will print I if basically what we are doing is that we are inserting ki with vi. I is a loop variable. It will change to 0 to 15. We'll inserting that one, and here bottom in the loop I am retrieving each value and verifying that's the value getting properly or not, just for checking whether code is correct or not. I think some changes. My HashMap 18 head is assignment to a constant variable. Okay, my HashMap. Yeah, here return the constant should be let because we are changing that value here. Yeah, it is returning all the value. That means it is not getting proper value. I will do one thing. What is the value we are getting? Let me check that one. we are getting null actually everywhere. Zero to 14. I think 15 is storing properly. Okay. Some problem is happening there. Hmm. I will do one thing. I will write some code here. We'll call dump. Basically for testing purpose, I will print the bucket so that we can see what and all data stored in the buckets. This dot buckets. Then I will print that dump here. We'll print the dump. Dump or dump? I think it should be dump, not a dump. It's a dump. It is stored only one value. Next entry K14. That's only one value it stores. No, actually, okay, it is storing K15, which contains K14 as a next entry. Okay, basically that bucket contains only one value. Okay. Get bucket index key, bucket index, head, null. Capacity is the 1. Okay, 0th index. Okay, the issue is that one we wrote a next entry here, but in the code we return next. It's not entry we return. Okay, added entry there. Now let me run it. Yeah, we didn't get any. Actually, we return some console log here that is not coming. Means all the value we have stored here is correct. If not correct, we need to print this one. That didn't happen. This is only a bucket printed. That means storing success. Okay. Now I will do one thing. I will increase the capacity to. Let me check that one. How now you can see bucket capacity is 2. We got 2 entries and we didn't get any error here. Storing success, actually verify is correct. Now we want to some visual data to see whether how this bucket is working in the code. So here we saw that one. Basically we have to define one array of linked list. It's an array of linked list. That's what we have done here. In the my hash we created a buckets. It's a array which contains linked list. So we need to do the visualization to see this one properly. So what I will do is that one I will print that one here dump. I will do JSON dot stringify. I'm not sure how much it will work. I will try that one. I will modify later. If it is coming. Okay, I will do one thing. I will basically currently uh, it is an array of linked list. I will do one thing. I will make it instead of array linked list. I will make a multi-dimensional array at the time of dumping, so that I can use in here I wrote some application I created. Basically here what I'm doing is that I'm showing all the buckets, each bucket, and it's a key. I will show here the code I wrote. For that I need array of array. Basically what I will do here is constant main array. So here how to print all the array here, I'm not sure that. This dot buckets dot for each will work. Okay, for each key value. I'm not sure the syntax. I will try and understand what is the syntax for that. Console dot key value. This is a function. Yeah, first we are getting value. First we are getting value. Then we are getting the index. So this is the value. Then here we are getting the index. Okay, so okay, so we need to initialize each array of key. I will initialize with empty array. Basically it's a main array. Let us call it main buckets. I will call this buckets. Buckets. So first bucket will array initialization, array initialization. Then we need to use this loop. So basically what we need to do is take this bucket. Yeah, bucket index here. I will add instead of key bucket index, I will add bucket index. So we got that one, and yeah, this is an array. We dot push. Basically we are creating an array which contain head dot value. I will show how this will come rather than I am explain here. Okay, yeah, we took that bucket, and basically bucket is an array of linked list. So I'm converting that to array of arrays, so that I can this application I wrote wanted array of arrays, not array of linked list. So here I will use the buckets. You can see currently it didn't print like that. No. Yeah, you can see here. It's an array of arrays. Yeah, this is a main array. This is the buckets. This is the first bucket, which contains value 1, 2, 3, like that. This is the value we want to create. Now I will add to that application view bucket app. I'll add to data.json. So now this application will take that one. Now here you can see here bucket 0 and bucket 1. How many buckets we defined here? The my hash map, how many bucket? 2 bucket we defined. And how many entries we inserted? 15. So you can see here 2 bucket, uh, 1, 2, 3, 4, 5, 6, 7, 8. 16 values we added. So we'll do one thing. We'll increase the capacity to 10. I will run that to code again. Now let me check it. Got some error. View bucket app. Oh, null is there here. Okay. Yeah, the reason is that on some buckets are null, not empty. So okay, bucket map, I will return that. I will do one thing. I will make the changes in that application. This is not part of my hash map. This I created it just for visualization. I will do one thing here. This is a next JS app. Yeah, it came here. Now you can see we have almost 4 buckets, and first 2 buckets are empty, and this second and third bucket are contain data. So how we find this bucket index? We are finding by the length of the string. This is a 2, this is 2. Here up to this point, length of the string is 2. That's why we choose bucket 2 and store there. And rest of them are length is 3, and it came here. Now this is not efficient actually. We see that one because we missed 2 buckets. We need to change the algorithm to find the bucket index. Currently we are looking for only size of the string. Okay, we created a 3 bucket. I will do one thing. I will increase the number of buckets. I will increase to, okay, it's a 10 we return. Capacity is 10, but you're showing only 3 or remaining. Basically it is not creating bucket with this much capacity. Okay, the problem is that we defined only 10 capacity, but here it's coming only 4. We need to create a 10 capacity array. Actually, this is not a hash map. It's not an efficient way of doing in JavaScript, but just for learning the algorithm, we do this one. So what do you need to set? Use the fill, and here tell null. Create a buckets of this size 10. Insert a null everywhere. Okay, so yeah, now you can see that almost 10 bucket we added. I will do one more thing. I will increase. Currently, we are adding 16 value. I'll do one thing. I will add 100. Do one thing. I'll add 200. Check 200 values. Inserting 200 value and checking. Now you can see clearly this is only using on 3 buckets and rest of the bucket is empty. So obviously this is not efficient. So we want to see, we are going to increase our buckets and we are increasing our entry in the buckets. So we want to find out some measurement to identify whether our algorithm is efficient or not. So how to find that one? What is the uh, ideal algorithm should do? For example, if we have 10 buckets and we have 10 entries, what should be the ideal algorithm? It should evenly distribute. It means each value should allocated in each bucket. So if 10 bucket is there, each should contain one, at least one item, at most one item, so that it will exactly added one by one. Here what happened is that all the three only 3 buckets contain all the data. The rest of the 7 buckets are empty. This is not ideal condition. If for example 10 bucket is there, 200 item is there. So if you are not going to increase the bucket size, each bucket should contain 20 value. That's a uh, ideal algorithm. So we need to do that one. So we need some measurement how to identify that one. So I will do one thing. I will write some metrics for that. My metrics will be like this. I will take this the same dump code. Here I will write efficiency 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 what is efficiency spelling? Efficiency. Okay, I forgot this one. Efficiency. Okay, efficiency point. Okay, how to calculate that point? Ideal values, each bucket contain equal number of items. So what I will do is that one let point is equal to 0. Let total, we want to find out how many total items are there. That's 0. So inside that bucket, each bucket, I will remove this bucket index, this one. We are taking the head, and in this loop we need to increase the total. We will increase the total. Basically it's the tracking how many items are there, and we'll do one thing. Let linked list item count. How many items in each linked list? 0. Okay, so what I will do is that one here I will increase this value, linked list equal to basically for first value is starting with 0. So what basically we are doing is here efficiency point we are calculating. Okay, I will do one thing. Linked list item count, I will just increase that one plus, and we'll go to next. Okay, basically what I'm doing is here I want to find the efficiency point, how whether hash map is very efficient or not. Ideally it should evenly distributed items in all buckets. So I'm trying to come up with some measurement to identify that one. So what I have done is that I created a point 0. This is the point we are going to return, and we want to track how many items are there. And we are going through each bucket, and we are counting that items. And here we return linked list item count. Basically, it is each bucket we are calculating. Linked list item count is starting with a 0. Then we are counting how many items are in a particular bucket. Then we are coming here. Here what we should do is that I will do one thing, point here, point plus here. So here linked list item is there count. If a bucket contains more than one linked list, we should penalize that one. I will add an algorithm like this. If it is contained only one, that's fine. 2 means you should penalize that one. 3 means you should penalize. Okay, I will do one thing. I will add 2 into. I will refine this algorithm later. Currently, I will do. I will increase point to. In some algorithm I wrote, it is nothing. So point by a total. So if this efficiency point is 1 means ideal. It is my hash map is ideally distributed evenly everywhere. So that's ideal condition. If the value is greater than 1, it means the hash map is not efficient. That's a simple point. That's what we have done here. We are counting how many values are there, and we are deciding point. Point is based on how many values are inside linked list item count. I think it will values 1, it will one, yeah, if the only one item is in the bucket, it will count as a value 2. So obviously it won't end with 1. So I will do one thing here. I will add -1. I will ignore if values is linked list item count is 0. If the bucket is empty, I will ignore that one. Okay. So efficient point we got. We'll do one thing here. We'll print the efficiency point dot log my hash map dot efficiency point. Let me check the efficiency point. 1.97 efficiency point. I will do one thing. We'll distribute evenly everywhere. How to do the evenly? I will do add here 1 and here I will add only one value, only one bucket and only one value. Now it should be efficiency point should be 1. Efficiency point is 0. That is not correct. What we have done now here, we default capacity is 1 and we inserted only one value. We are finding the efficiency count. Bucket value not this one, efficiency count this one. I think we are getting the value here, but I'm using this bucket index. Point by total is 0. Value 0 is getting. Let's print here console.log a point a linked list count. I'll check what's the value here coming. 0 1. Point is 0 and linked list count is 1. Okay, 1 minus 1 is okay. This calculation is getting problem. Okay, I will do one thing. I will define one function here. Sum of first n numbers. Okay, it's sum of n number it is finding. For example, if you are passing 1 as you are passing 1 for the sum of first n number, you will get 1 as a value. If you are passing 2, 1 plus 2 is 3. If you are passing 3 for the sum of first number, it will get 1 2 3 is a 6. That's what we are calculating. The number will increase actually. So basically, if the bucket contains only 1, we will consider value as 1. If the bucket contains secondary, that means 1 plus 2 3. If a bucket contains 3 values, 1 plus 2 plus 3 6. Basically, how much value you are adding 1 to bucket, it will increase not exponentially, but logarithmically, not logarithmically, polynomial it will increase, something like that. Yeah, that's what we are doing. So we using this one sum of first number to get that value. Earlier we tried to multiplication 2 into that linked list count. Instead of that one, I am going to do this one. So the formula for that one, n minus 1, n into n minus 1, n into n minus 1, this is the formula, by 2. For example, if we passing 1 minus 1 is a 0. It's not correct. sum of first n numbers. What's the formula? Sum of first n numbers formula. Okay, n plus 1, not n minus 1. Okay, this is the formula. N into you can calculate for 1 plus 1 2, 2 by 2 is 1, 1 into 1 1, correct. For 2 plus 1 is 3, 3 into 2 is 6, 6 by 2 is 3, correct. For 3 plus 1 is 4, 4 by 2 is 2, 2 into 3 6, correct. So that is the I'm going to use there. We don't need to check whether contain or not. Need to reset this here. Yeah, we got the value 1, correct. Basically what we have done is that we are finding two values. One is the total number of items, another is one more number we are finding called point. This point will find calculation of the point is happening like this. If the bucket contains only one value, we will consider as 1. If it contains 2, we will increase the penalty. Instead of calculating the 2, we will calculate 1 plus 2, 3. One more item is in the bucket, it will increase one more time. 6, we will calculate the 6. Anyway, this is not a perfect, but it is fine. For the time, it's fine. So I got a bucket with one value, and efficiency point I got as 1, correct. That's mean ideally it should be like that. Okay, I will do one thing. Generating that data JSON so that I can view in the application. Yeah, 0 bucket and only one value. Now I'm increasing 2 value in the two. Okay, I will do one thing. I will increase the bucket size to 10, and here I will pass entry 100, 10. It's not evenly distributed actually. Yeah, you can see here all the values are inserted in the same bucket because we are we are generating the bucket index based on the size of the string. 2, adding 200, we got only 10 bucket. Yeah, it is distributed only 3. So we need to find out a better bucket index. Currently we are finding string length of the key. Here is a 2, so it went to bucket 2. Here is a 3, it went to bucket 3. So our bucket index generation from the key is not efficient, so we need to change that one. Let us check the efficiency value here. What is the efficiency value here? What efficiency value is not at all printing? Okay, it went to, I'm printing a lot of thing here. I will delete this one. Yeah, 46. Basically, ideally it should be on. It came 46. So how to? The problem is that one we are. Okay. So we want to make sure that when these values are evenly distributed in all the other buckets. So we need to change the bucket index generation from the key. So here this code need to be improved. This hash code, instead of key length, we should do something else. So what I will do is that one key is a string. We'll do one thing. We'll convert that string into array. Then I will use reduce, which will contain sum and value. Basically it will take each value and will basically it's a reduction actually. Initially you need to pass 0 here. First 0 and first element will come. It will S will contain 0 because I gave 0 here, and C will contain the first element here. Then we'll do the computation here. I will add S plus C. Parse into, I will convert that string into S actually will contain number only. C will be a array, sorry, a string. I will take char coded, char coded first 0th char code. So basically what I'm doing that one, I got some string and I converted that into array. Each will contain one character, but in JavaScript is a still it's a even if it is a single character, it's a string of single character. So it will contain, it's a reduction is happening basically. Here I given 0 as a first value. It will take the first 0 and first character in the key, and we'll do this computation. S is a 0 first, then we'll convert the char code. It is actually integer of this first character in the string, and we'll do the addition. Then we'll get a value. That value next iteration will come as S. Then next character in the key will come as a C. That's how this reduction is working. Okay, let us try this one. Yeah, it is perfectly working. Wow. Exactly, bucket contain all the values, evenly distributed everywhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is perfect. I don't think so our efficiency code will work because that's not designed like yeah, that efficiency code will work only if each bucket contain only one. Currently it won't work actually. It won't return one actually because our efficiency code algorithm is not good. We need to change that. I will do one thing here. 10.5 we got. Okay. Okay. So we need to make some changes in the efficiency code. Bucket capacity. Okay, I will do one thing. I will take this capacity. Need to consider the capacity also. Point into capacity. This value capacity by this one. 1.05. I don't think so. That's we should get 1 actually, but I'm not getting the 1. Anyway, I don't want to spend much time on this efficiency point. It won't make much sense actually. I will do one thing. I will increase this to 50. Zero point 1456. Okay. I think it's all the code is written already 1 hour gone. I don't want to spend much time on this. I will end this one. Yeah. Wow, nice distribution. Okay, so it's not evenly distributed. So the problem is this key. The key we wrote not a good one. This is not a good one. So I will do one thing. I will here basically what we are doing that one. We taking the key value first key plus second key plus three key. Basically what we should do is that one. This should be multiplied by 100. This should multiply by 10. It should multiply by 1. That's how we should calculate this sum. So I will do one thing. I will multiply with 10. Now it will evenly distribute. Reference key is not defined. 35. Okay, somehow I made some mistake here. Yeah, done. Oh, yep. Wow. So good. It's evenly distributed in all the buckets. Let us take the our efficiency code. That's not a good code, but yeah. Just for let us take it should be close to 1 and not 1 2 3 4. Yeah, this efficiency code is not good actually. Yeah, I think this should not add here. 2.55. Yeah, this is fine actually. I think it is fine. Okay, anyway, we have done that one. Okay, default capacity is 50, and basically what we need to do is that one, whenever entry is increasing, automatically the capacity should increase. That we didn't do here. I don't think so we have much time. It's already 1 hour code. Okay, basically what we need to do is that I didn't delete also, I didn't do here, and there's some more thing I didn't do here. If you are putting the value once again, we didn't check that. Here what we are doing, we are not checking whether the key is already existing or not. Okay, I will. Okay, I don't want to spend more time. I will do one thing. I will make small changes here. Here, okay, we'll do the dump here. I will comment all the stuff. So basically, I want to show that on some error in that code. What I will do is that one here. My put adding key 1, adding value 1. I'm adding that is twice I'm adding. Okay, then I'm dumping that one. How it is stored in the buckets, that's what we are going to do. We are going to check. I will reduce the bucket size here so that I can see easily. Yeah, you can see here it is K1 stored twice. The reason is that in the put time, we are not checking whether the key exists or not. We are simply trying to add. So what we need to do is that take this code. And once you got the head, go through loop that one. If we found that head, head value is equal to value, then return. If it is not there, then only add this entry. Okay, basically what we are doing is that we are taking that head of the linked list and going through that one and checking whether a key already exists or not. If it exists, we just change the value. That's it. So let me check it. Now you can see we stored only one key because we checked here. And what else we need to do here? Put key, we made some changes. Get, we don't need to make any changes here. Okay. We need to write a delete key also we need to write here. How to write a delete. Delete is like I'm not sure how to delete to do that. We need to write the delete part. I don't think so we have time because it's already 1 hour. I don't want to go beyond that. We need to write a delete here. I'm not going to implement now. I will write delete. I think delete is a keyword. I will tell this or keyword delete or keyword in JavaScript. Delete is keyword in JavaScript. Delete is keyword in JavaScript. Okay, delete not deal. Okay, we need to define one variable, one function is a deal. Okay, that we need to do. Another thing what we need to do is that we need to increase capacity automatically. Here in the put, basically what we need to do is that we need to check increase the capacity or not. For that purpose, what we need to do is that we need to define one variable size. This dot size equals 0. This will tell how many elements are there. So in the put case, we need to increase the value, and delete case, delete the success, we need to decrease the value. If success, the item is not there, we don't need to minus, like that we need to do. Then here what we need to do in the put, we need to check if size, this dot size is equal to this dot capacity. If it is a capacity same, what we need to do is that we need to increase the arrays. JavaScript, okay, we need to increase that one. So what we need to do is here, we need to store the old array and initialize the new array. How we are initializing here? Okay, need to initialize the new array here. Basically, first store the old array, store, then I'm not going to test this one, but I will explain here. Capacity, you need to increase the capacity. Say capacity increasing by 16. Every time if this overflow is happening to the bucket, we'll increase the bucket 16. We'll add 16 more bucket. Then we'll initialize the bucket again here. Okay, I will do one thing. I will constant, I will do that one. And basically I'm resizing that array here. Here old buckets we'll go through the old bucket. Yeah, here actually we use the value actually. This was the bucket. Yeah, instead of the old bucket, this following code we actually you didn't use this value actually. Instead of the value we used like this you used. We can use actually head, define head this as head. I think that was cleaner code, but I didn't do that. Here also actually you can do the same thing. I think buckets, no, here actually we need index. There actually we don't need index. Anyway, I'm not going to optimize that right now. here old bucket, we will get the old bucket, and old bucket old bucket will be value here. Head will considers instead of old bucket I will add a head only here. Here this dot puts head key, head value. Basically inserting that, basically we want to increase the bucket size, so we are storing that old bucket into old buckets, and we are taking each value and pushing again to new bucket. So you need to say the key and value. Some errors come here. Okay, here this node should be okay. Expansion is happening here. Yeah, here we are increasing the capacity whenever the size is equal to capacity. Okay, we'll do one thing. Run again. Here adding 200. 200 I will add. Assignment to constant variable. HashMap 48. Okay. Somewhere return some console. Console.log, that's fine. I don't know from where it's coming. I will do one thing. I will printing the number. Where the number is printing? I think it is coming from here. It's coming from here. I think that's expansion is failing. Actually, once we need to initialize this on to 0. I don't know, that's a problem. Okay. Capacity is 10, capacity increased. We are taking all the buckets and we are increasing the capacity. We are defining the new array, and old bucket we are taking head and pushing this value. Then go to next. assume I will do one thing. I won't enter into this block at all. Need to make sure that's a no. Something else happened. Some other changes screwed up. I think somewhere else I made changes. Maybe this changes screwed up. No. Two hundred. I press. Okay, the problem was you can see here only last 10 elements are stored. That means it is losing the rest of the values. That can happen because this head value is become null. So you can see here I just added this code. So basically this head will end with null. That's the problem. If I'm removing this one, it will work fine. So you can see everything came. So here we need to do one thing. Old head let head equal to old head, and that old head should be used here. Old head okay, so I will do one thing here 10. Here I will do one thing 10. I will add this 10 value once again, because we are adding some duplicate there because we are not checking the key earlier. Is this working fine now? Old head. Let me check the data file. Inside app it's a data. It's not repeating. Why? Okay, I return here. That's the problem. Basically, I'm expecting duplicate data there. Yeah, now duplicate data came here. So to avoid the duplicate data, you need to add value here. Yeah, it took. Okay, earlier problem was yeah. I don't need to explain that. I just skip this one. It's working fine. And now we need to make sure that capacity increase, automatic capacity increase is working. That's what I want. to make sure that that's the last thing I'm going to do here today. 10. Here, yeah, it is increasing the capacity. Here you can see the 16. How many buckets are there? 200 bucket. Yeah, it's evenly distributed. A lot of empty bucket is there, but what did create a 200 bucket? Yeah, it's increasing based on the number of items. Okay. Yeah, it's not a bad actually, because maximum it is 2 is there. So basically, if bucket contain only one constant time, you can retrieve that value. If 2 means it is need to go to first element, then need to go to second element. So iterating twice. That's not bad. That's not a bad thing actually. Obviously, there are a lot of empty buckets there, but it is not about having several values in the each bucket. Only 2. That's not a bad thing. Empty is not that much problem. Okay, it's a if it's any failure is happening, I will it will tell whether failure happening or not. Not that much failure happening. Okay, we'll do one thing. It is automatically increasing the capacity. I will do one thing. I will add here 1000, here 1000. Let us check what is happening for 1000. It's evenly distributing. Oh, not bad. Yes, so maximum 2 only I saw. So it's a good implementation, not bad. I will add 10,000, adding 10,000 elements. I think some loader problem is there. I'm not going to fix that one. I will check my efficiency point, how much efficiency points happening here. Yeah, 1.0.1. That's a good only because it's not coming multiple. Anyway, now that's all. I will explain once again what's doing. Basically, I wrote a HashMap implementation and initializing that class and inserting almost 1000 elements, and k plus I is a value, loop value, and I am verifying here whether I was able to retrieve properly or not, just to make sure that whether it's working or not. So here wrote one class entry that contains the key value and the next entry into the value, because we saw this picture here. Basically, HashMap is a array of linked lists. Array of linked list. So a linked list entry, this linked list entry. So it should contain pointer to next entry. That's the next entry. And now HashMap. In the HashMap, we need a capacity. I wrote a default capacity, and it initialize the buckets using this array, initializing that capacity. And we wrote to get. Basically, it is finding the corresponding bucket index for that key. Then we are taking that bucket. Basically, we are getting the head of that linked list, and we go through the linked list and finding value exists or not. That's how we do the get operation. The put operation, first we need to check whether items and capacity are equal, then increase the capacity. That's increasing capacity part, this one. Now here we are saving part. First you need to find the old head. and go through the linked list. If the key is already there, just update and return. You don't need to do anything else. You don't need to create new entry. Otherwise, you need to create new entry and make the old head as a next pointer into that entry, then add that entry to here. That's all. There are a lot of other things you need to do here. You can see Java. There are so many other functions there. One important function I think omitted, load factor. Load factor we didn't touch. Yeah, they didn't mention what is the load factor. Anyway, I'm not going to explain that one. That's all. How much time took? 135. Anyway, thanks for watching.